Hello. Obviously, again, my name is Drees Elho, and this is my technical UI demonstration video. This is my technical UI demonstration video. So first things first, I'll come to my Rocket Elevators page, my quote page, and I'll just test everything out. I'll just test everything out, kind of. This is from the user's perspective, and then in the second part, I'll go into the code and explain how some of the main components are responsible for the form's behavior, because this is a static form turned into a reactive form. And and I'll also show some of the calculations and do a visual representation of them as well. So this quote page is designed as a progressive three-step form. So as you can see, the first step is locked up until you select your building site, and then you fill in the information you need, the accurate information, and then you get the second step, which is the product line, and you can pick a product. And the third step would be just reviewing the price and then submitting the form. Um, this page is not a static page. So if I switch anything around, if I switch any of the details, the number of floors maybe, if I do anything like that, um, you see the numbers on the page go up as well. So you don't have to reset this page. You don't have to input a certain value into this page for anything to happen, for anything to work, because this is, this isn't just like a static page. And also, when you switch the building type, everything resets to 0. So the calculations don't get skewed by numbers that are irrelevant to the situation. The three supported building types are residential, commercial, and industrial. Each option requires different information and they all have different sets of information. So the form adapts dynamically to the user's selection. So first I can begin with residential. Once residential is selected, the form displays fields for the number of residents and the number of floors. For this demonstration, I'll use 100 residents and 20 floors. As soon as both values are available, the page calculates the recommended number of elevators, so that being 7, and oh, I thought I was tripping. And the product line selection only becomes available after, or visible, after both of these text boxes are filled out, and the estimated price option will only become available after the product line option is filled. So next, I'll go briefly into the product tiers and the live pricing. So we have 3 tiers: standard, premium, and Excellium. Each of these varying in price, standard being 10% of the entire price as an installation fee, the entire elevator cost, premium being 15% of the entire elevator cost, and Excellium being 20% of the entire elevator cost. When I select premium, the chosen card gives me a visual highlight. The estimate appears almost immediately. Well, it appears immediately, actually. And 7 elevators at $12,000 per elevator comes out to $84,000, the elevator cost. 15% of that being $12,600, with the final price being $96,600. These amounts update automatically. You don't have to refresh the page. You don't have to click an input button. You don't have to do anything like that. Next, I'll go into my commercial example. I'll do 120 occupancy and 12 floors. This comes out to 8 elevators. I'll select standard, which comes out to 8,000. Which standard is $8,000 per elevator. The elevator cost being 64,000. 64,000 divided by 8 is 8,000. The installation fee being 10% of that, which is 6,400, and the final price being $70,400. So for industrial, I'll swap to that as well. They all have different options. Industrial's only option is number of elevators, because for most industrial sites, you won't need to know the occupancy, and they will really just need to know how many elevators they need. The number of elevators required also updates dynamically, because as you can see, the more numbers I add, it updates immediately. It immediately recognizes that I'm putting in more numbers. When I put zero, the number of elevators required, it defaults to 1 for industrial always. So overall, the interface uses conditional fields and step-by-step disclosure with automatic calculations and currency formatting. and currency formatting, giving immediate visual feedback to make the coding process the most straightforward it can possibly be. Um, Next up, I'll go into just a little bit. I'll just dive into a little bit of the code explanation. So first, I'll go to quote.html. So yeah, the form has the ID quote form, which makes it to where when you're at index.html or residential.html or even commercial.html, there are all links that link to the quote form directly. So nobody has to do any extra steps. They click one button and the quote form is immediately on their screen. Below that is a collection of dynamic fields for residents, occupancy, floors, the manually requested elevators, quantity, and the calculated elevator quantity. All possible fields exist in the HTML, but the JavaScript and the CSS decide which ones should be visible. This the second step contains the three product cards. Each card has a ratio. Each card includes a radio input, and a data value. So each card gives you a radio input, which gives you the type of button. It's a little circular button. And as you know, we need a radio buttons for this project. And the final step contains four output elements. You get the unit price, the elevator cost, the installation fee, and the total cost. Next, I'm going to go into my quote CSS, which is basically the cascading style of the entire page. The dynamic fields are hidden by default, but when JavaScript adds the class, the selected fields become visible. The same idea is used for the form's major steps, classes such as one complete and steps such as step one complete and step two complete, as you can see here. You get step one complete, step two complete. The main application logic is in the quote.js, and all of it is placed inside a DOM content loader or listener, which ensures that the HTML is available before the script tries to access it. Because if you didn't know, um, it reads it top down. So you want the JavaScript to be after the HTML because you don't want the Java to load before the HTML, or the entire site is going to crash. The tier config object, can pull that up. So the tier config object stores the unit price and installation rate for each product line. Keeping this information in one configuration object makes the pricing rules easy to locate and update. The field map object connects each building type to the HTML field it requires. Residential uses residents and floors, commercial uses occupancy and floors, and industrial only uses the requested elevator quantity. The form state and validation. So, do this right here. So as you can see, we have clear form values here. We have update dynamic fields. Update dynamic fields, and is step one complete. So when the building selection changes, clear form values removes old field values and product selections. The set form state function enables the remaining controls, and update dynamic fields adds the active class only to the fields associated with the selected building type. The is step one complete function oh my gosh, sorry, misclick. The is step one complete function provides front-end validation for the progressive interface. It checks the building type and confirms that its requested fields have values, and the next step is not displayed up until this function returns true. The numeric inputs also use a minimum value of 1 to restrict typed content to whole numbers, so no decimals, no negative numbers, nothing but whole numbers for the elevator calculations. And last but not least is the actual elevator calculations and the price calculation updates. So So as you can see, this function right here, this get elevator count, each building type has a separate elevator calculation function. Let me see. Yeah. So each section has its own function. So for residential, the number of residents is divided by 20. Let me just go here. Here it is. Here's the math for residential. So for residential, the number of residents is divided by 20, and the number of floors is divided by 10. But both values are rounded upwards and then added together using CEO, CEIO. For the earlier example, 100 residents produces a ratio of 5, and 20 floors produce a ratio of 2. Together, that gives 7 recommended elevators because 100 divided by 5 is, 100 divided by 20 is 5, and 2 divided by 10 is 2. So you have 5 plus 2, which equals 7 elevators. And then for commercial projects, the occupancy and floor count. So for the commercial projects, let me find the math for that. It'd be right here. The occupancy and floor count are compared against baseline values. The larger ratio is multiplied by a base quantity of 3 elevators and then is then rounded upward. So for industrial project, and then for industrial projects, which will be here, the calculator uses the elevator quantity directly entered by the user to get the required number of elevators. The getElevatorCount function acts as a dispatcher as it maps the selected building type to the appropriate calculation function, while then this keeps the building specific formula separate and makes the overall code easier to maintain. As you can see, you have your industrial elevator count, the commercial elevator count, and the residential elevator count. The industrial elevator count being a lot shorter because there's not really any math that goes into it, as the site uses the exact number typed in with as the baseline for the industrial. As with commercial, the Java actually has to do the math to figure out how many elevators, and the same with industrial, or residential. And then last but not least, the price calculation. So this function, update pricing, is the central calculation that takes place. First, it checks whether step 1 is complete. Then it retrieves the selected product configuration and the calculated elevator count from step 1. The elevator cost is the unit price, so I can show you better than I can tell you. From step 1, the elevator cost is the unit price multiplied by the number of elevators. So here I'm still on premium. I can switch it to standard and become 8,000 per elevator for 2 elevators, which is 16,000. The format currency function provides every amount of consistent US currency formatting, which gives you the dollar sign, the decimals in the thousands, the commas in the thousands, and the decimals here, just in case any change were to occur. The input and change listeners. So I'll go back to the code. What makes it dynamic is that the add event listener has an input and a change listener, so that whenever the user edits the form, the 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 page is updated almost immediately. Like the quote form will respond immediately. You will not have to update the page, restart the page, input anything, or even click a button. As soon as you put the number in, the page will update. So to summarize, the quote page uses semantic HTMLs, a state-based CSS, and a modular JavaScript to create a responsive and interactive quoting experience. The interface reveals only the information relevant to the selected project and discards everything else from no matter what you typed. It calculates the elevator requirements using building-specific rules and generates a transparent price breakdown in real time, without the need to have to reset the page or input any buttons. The current submit request form, the current submit request button completes the visual workflow, connecting it to a persistent storage or a backend quote API, which would be the next developing step, which I hope to work on later. Thank you for watching Mr. ET.